everyone, welcome to Siddham Robotics. Today I will be showing you how to run a motor using Arduino and L298N Motor Driver. So we will be using a BO motor, then 3 lithium ion cells, one 3-cell battery holder, our hero Arduino Uno, and our next hero L298N Motor Driver. So let's get started. Okay, so now I'll be showing you all the components required. So here we have BO motor, a wheel, Arduino Uno, L298N motor driver, 3 lithium ion cells, lithium ion cell holder, a multimeter for testing and debugging, few male to male and male to female jumper wires, and Arduino Uno, the coding cable. So let's get forward. Before starting, let me tell you the safety and security rules for your home safety. Whenever you're making such electronics project, always check polarity. Your each and every component has some kind of polarity. So for example, this battery cell has a plus and minus polarity, and if you're not considering the polarity well, the components might get damaged. Okay, the next is always remove power before changing the wires. So just in case if you're making a circuit and it is not working, if you want to make some changes in the circuit, it is always preferable that you need to remove the power. So if this is connected like this, you need to remove the power and then make the changes, and after that, once you have confirmed all the connections, then you can power up your Arduino and your motor driver using the batteries, and then you can test it. The next is heating kind of issues, like if your Arduino is getting heated or your IC of your motor driver is getting heated too much, immediately disconnect the circuit and wait until further check. So now, before inserting your batteries into your cell holder, we need to check individual battery cell voltage. For that, we need our multimeter, and we need to set the multimeter towards the 20 volt DC, towards the 20 volt DC parameter checking. Next, I will connect the positive and negative terminal of the battery to the positive and negative probe of the multimeter and check the readings. So as you see, here I am getting 3.55. So this cell is okay. Next, I will check this cell. Here 3.54 works, and the same here I am getting little low 2.86, but it will still work. Now once that is done, I know that my individual cells are powered enough, that is more than 2.8 and around 3 volts or 3.5 volts. Next, I will insert them into the battery cell holder. Before inserting, make sure you're inserting in the correct manner according to the polarity. So here inside your cell, in these grooves, you have these minus and plus symbols. So connect the battery accordingly. The minus point is always towards the spring. So if this is the spring, the minus point of my battery will always be facing the spring. Okay, done. Now, since this is a new battery cell holder, what we need to do is, now the output wires, the black and the red, we need to check the total voltage of these 3 cells from the battery pack we have just made. So my multimeter is on, and now I'll check what is the voltage. Okay, so currently what I am getting is, I am getting 0.01 or something. It means the connections are still loose. So even if this may seem, even if you see that the connections are correct, plus minus and plus minus, it is in series, okay, kind of a Z plus minus series, it is okay, but still it is not showing me the proper full voltage. It is showing me 0 volts. So this is not working. So how to make it work? You can see here we have these batteries and there is a gap in between this. So what I need to do, I need to push the battery in the cell holder from the minus to the plus. So I'm gently pushing it from the minus to the plus, from the minus to the plus like this, and from the minus to the plus like this. So now I'll check again if this is working. Yes. So now when I check, I get a total voltage of around 9.96 to around 10 volt I am getting. So now we are good to go. Okay. So now our battery pack is ready with 10 points output voltage. Again, I am telling you some of the points to be, or some of the steps to be followed. So insert the batteries and make sure the markings are correct, the plus and minus markings. After that, push each cell until it sits firmly. Okay, so each cell should fit in firmly into the cell holder. Okay, and then you can turn the holder around and check if the connections are actually connected towards the spring and the other side. Okay, and then you can check with the multimeter, the black and red probe, and you should get the total voltage of around 10 to 11 volts. Okay, now this is your L298 motor driver. A quick revision about what a L298 motor driver is. So it is basically and H bridge motor driver. Okay, it is an H bridge motor driver. Okay, it is an H bridge motor driver. What is an H bridge motor driver? Basically what will happen is, if you have a logic like this, okay, so you have a logic like this. Okay, here you have ground. This symbol is for ground. Okay, this symbol is for ground, and then here you have, for example, plus 12 volts. Okay, so now here between these connection you have a motor. I am representing it as M. Okay, so now here you have terminal A and you have terminal B of your motor. So in this case, if I give plus 12 volt from here, it will flow in this direction, it will pass through the motor and it will go towards the ground. So this will be the flow of the current from this side, entering from this side into the motor. I am showing a small arrow. Then it will continue towards the ground like this. That is the first way possible. The second way possible is from this 12 volt to this ground. Okay, so it can be here. So it will be entering the motor from this terminal, from this side. Okay, and then it will be carried to the ground. Okay, so what this makes difference and how we are using and why we are using it. Okay, so we are using this principle, we are using this basic thing, and hence it is called a H bridge because it looks like a H. Okay, so what we are doing, we are changing the polarity of the motor power. Okay, so for the first trial, this is the second trial we did. Okay, so the second case, for the first case, the current is entering, the 12 volt is entering from this side, and then in the second case it is entering from this side. What does this make? This makes a difference that your motor direction will be changing. So if you want something, a device that can change the direction of your motor without actually changing the wires in between the project. Okay, so if you have made an entire RC car project and if you don't want to keep changing and twisting the wires to change the direction of the motor, what you can do is you can use this motor driver, and it can change the logic of the IC using the Arduino. Okay, using the Arduino we can change the logic of this IC, and then it can eventually change the direction of the polarity direction of your motor, and it will be rotating in clockwise or anti-clockwise direction as per the logic of the code. So that was little introduction about what an L298 motor driver is. Now setting up your motor driver, for this video we will be using the only one output channel. Okay, so you have in total 2 output channels. So here, this is the main IC, this is motor B, this is motor A. So you can attach one motor here, you can attach another motor here. Next, these are the power lines. So here you can see it is also printed on the PCB that what are the specific pins. So here it is 5 volt, ground and 12 volt. So from this pin is 12 volt, the middle pin is common ground, and this extreme pin is 5 volt. Okay, next these jumper wire pins is actually for the logic pins. So these pins will be connected to the Arduino, and these are for power, and this will be connected to the motors. Now quickly we will do a small fixing. So for that, in order to control the speed of your motor, okay, we are controlling the direction of the motor using the logic pins from pin number IN1 to IN4. So IN1, IN2, IN3, IN4. These 4 pins are used to control the direction of your motor. It will be rotating in clockwise or anti-clockwise direction. But if you want to control the speed of your motor, you need to use the enable A and enable B pin for motor A and motor B respectively. So for our case, we will be using just motor A side. So I am removing the jumper, this small jumper. Okay, I just pulled it out. Okay, it was connected like this, and then I just pulled it out, and then I freed the enable A pin. I removed the small jumper from the enable A pin. This was the small jumper. I removed it from the enable A pin, and now we can use the enable pin to control the speed of the motor. Next, I'll keep the jumper safe aside, and I'll do the connections. For that, we will do the motor connections. So this is our BO motor. So basically this is a DC motor, and this yellow part is the gear of the motor. So this is a DC geared motor, and is commonly known as a BO motor. It is dual shaft, so you can take output from here and here as well. Okay, so for now we will be connecting this. I will be using a screwdriver and gently loosening the screw in these 2 terminals. I will rotate it anti-clockwise in an anti-clockwise pattern, and I will just loosen the screw. Okay, so now if you see this here, we need to connect the pins. Okay, we need to connect our pins here. As you can see, I am able to insert the screwdriver here inside this. Okay, I am showing you again. You need to connect the wires inside the side. Okay, inside this screw terminal from the side. Okay, so here plus or minus doesn't matter. We can change the direction later in the code logic. So I am simply connecting in any way possible. Okay, what I am doing is I have just done this. What if you can do, if you don't want, you can do it one by one. So I have just put the wire here. I'll hold it gently and then tighten the screw by rotating the screwdriver in the clockwise direction. Okay, so I have gently tightened it, and now you can try by gently pulling the wire, and it is not moving out. So we are good to go. I'll do the same for the second wire as well. Okay, so I have tightened it firmly. Now none of the wires are moving out, so we are good to go. I am just checking it and it is working really well. Next, what I will be doing is I will be making the logic connections. Okay, so for that we need our Arduino Uno and few male to female jumper wires. So for now I am using these male to female jumper wires. The female side goes in iron pin 1 and iron pin 2. Okay, so I've connected it here in iron pin 1 and iron pin 2, and now this two goes to pin number 5 and pin number 6 respectively. Next, I am taking another male to female jumper wire. Okay, so I am taking another male to female jumper wire. The female connection will be going to the outmost pin of the enable A. Okay, done. Now this will be going to any of the PWM pins. Okay, we need to control the speed of the motor using this enable A wire. So the logic should be from a PWM pin. So I am connecting it into any PWM pin. For this instance I am connecting it to pin number 3, digital pin number 3. Okay, so the connections are done. I am repeating the connections. So the connections are iron 1 in pin number 5, iron 2 in pin number 6, and enable A in pin number 3. Okay, so these connections are done. Now we will move towards the power connections of the motor driver. So here is my battery pack. I am again checking the voltage, the total output voltage from the battery pack. Here is my multimeter. The multimeter is set to the DC 20 volt. The multimeter is set to the DC 20 volt. And now I will be touching the output wires from the battery pack, the positive and the negative red black wire, and check the total voltage. So here I am getting a total voltage of 9.96. I hope you can see that. I am getting a total voltage of 9.96, which is sufficient for my application because I am just using the single motor. Okay. So now what we can do is we are good to go for the further connections. Now I am just connecting the 12 volt. This red wire will be going to the 12 volt power supply in. If you are confused, you can see at the backward it is printed plus 12 volt. I'll simply loosen up that screw. You can rotate anti-clockwise and you can loosen the screw. Okay. Now this is done. Okay. I firmly fitted this. Now for the ground wire, what you need to do is you need to also take a male to male jumper wire. You need to also take a male to male jumper wire, and then you need to loosen up the center screw. Okay, so from these three, you need to loosen up the center screw. You need to insert the male to male jumper wire as well as the negative wire from the battery pack. Okay, both needs to be inserted in the same terminal. So the ground will be common. The ground will be common. I am repeating, I have inserted the negative from the battery pack and the ground into the same. So after checking, it was loose. Okay, so I need to push it back in properly. So I'm again loosening it up and inserting it from the sideways and then firmly fit it properly. Okay, now it is okay, we are good to go. Okay, so now as you can see, if all your connections are correct for the power, the red LED in the motor driver will be on. Okay, it will be continuously on. We have an onboard LED red color. It will be continuously on when the connections are proper. Now I will just push this cell and show you what happens if the cells are not connected properly, or these wire connections, the power line connections, the red and black wire, if they are not connected properly, I will show you what will happen. Okay, so now what I am doing is I am gently pushing this middle cell. Okay, so now as you see, if this is loose, okay, if this is loose, it means I am not getting the total power and the light will blow off. Okay, it will not glow, but if it is proper, it will be directly glowing. Okay, see. Okay, now why am I showing you? Because this is a very critical debugging step where we face challenges. Some kids face challenges in, like, the battery individual cells are okay, but the complete battery pack, they get 0 voltage or very minimal voltage, which means there is some issue with this. And then even if you're getting total output, so if you have checked from the red wire and black wire on the multimeter, you're getting 10 volts or 11 volts, whatever, and still if the light on the motor driver is not glowing on, that means the connections, the positive and negative connection to the 12 volt and GND pin are loose. Somewhere the connections are loose, so you need to check that. Next, when that is done, we can move forward. Okay, so now the ground wire, the common ground wire which we took from the male to male, we need to connect that wire to the GND pin of your Arduino. It will be connecting to the GND pin to the Arduino. Now make sure we have not connected anything to this 5 volt. This 5 volt, nothing is connected to this 5 volt pin from the motor driver, and no connection is made to the Arduino as well. The Arduino has only minimal connections. What are the connections? Just the IN1, IN2, enable A pin, which are the logic pins, and only the ground is connected. In further projects where you are making an RC car, where you cannot power up your Arduino using the cable wire from your laptop, the USB cable wire from your laptop, in that case we will be using the 5 volt and you will be connecting that to not the 5 volt of your Arduino Uno, but rather the V in pin, the V input pin in your Arduino. We will be using the 5 volt from the motor driver to power the Arduino, and it will be connected to the ground and V in pin, not the 5 volt pin, because 5 volt is the output pin of the Arduino, not the input pin. If you want to power up the Arduino using the jumper wire, you need to use V in pin. For now, the connections are done. Now we will be preparing the Arduino IDE code. We will go towards the screen now. So now we will be doing the Arduino programming. For that, you need to open the Arduino IDE application. Now, if any previous code is still open, what you can do is you can press Ctrl plus N key on your keyboard and you can get a new sketch. So now we have a brand new sketch. So here I will just give you a quick introduction of the platform. Here on the top you will get the first button, which is the verification button. It is used to verify the code for any errors before uploading. The second is for uploading. Next, here you have some options. The first one is file options, edit options, sketch, tools, and help options. On the top right, you have the serial monitor option, and all the output of the serial monitor or the code errors will be reflected here at the bottom part. Okay, now let's start. This now is the void setup and void loop. Okay, this is already given. So now we will start with the basic coding which will make our motor driver work. So for now we will be first defining the pins. Okay, so we connected the Arduino and the motor driver with 3 pins. So the first pin was IN1, IN2 and then enable A pin, which is the ENA pin. So we will quickly define that. So I'll type INT, that is integer short form. Then pin name is IN1 and it is on pin number 5. Next I have int IN2, it is on pin number 6. Next I have INT integer and then ENA pin and it is on pin number 3. Okay, keyboard shortcut Ctrl+T is for auto formatting. Now I can add some comments as well. For adding comments I am using // so this is the motor logic pin for direction control. है ना? This pin will be used for direction control. Next, pin number 6, same. But pin number 3 is unique. It is a PWM pin and it will be used for controlling the speed of motor. We will be using this for controlling the speed of the motor. And pin number 5, 6 IN pins are used for the direction control, that can be clockwise or anti-clockwise. Okay, so now the initial code is done, which is the pin defining. Now we will write the void setup. In void setup the code runs only once, okay, at the time of starting the code. Then it will never code work again, and in the loop we will write the code here which will be running repeatedly, on a repeatedly loop basis. So here I am writing pin mode. Okay, now pin name, which is IN1. So it is output from the Arduino. Okay, it will be output from the Arduino and then it will be input for the motor driver, है ना? If it can be it will be an output from Arduino and input for the motor driver. I hope that is clear. So quickly define the output. All pins are output. Next, pin mode. Okay, be very sure and be very cautious of the capital letters or the small letters and how everything is to be written. Okay, now here ENA, it is also the output pin. Okay, so now this is not properly formatted, है ना? This is not properly formatted. The pin mode here is written like this. It should have a indentation and then here it is no space. Here I have space. Okay, so to make everything proper, neat and clean, what you can do is use Ctrl+T keyboard shortcut and it will be auto formatted. So now it is automatically neat and clean, and you'll also get a message here that auto format is finished. Okay, so now this is done. Pin definition is done. The pin mode is set to output. Now we are ready for the main code, which is the loop code. Now I am writing for case 1. For case 1, what we will do, just simple code which will make the motor on for few seconds and then off for few seconds. Okay, so now digital write IN1 and then high. Same for IN2, digital write, and IN2 will be low. Now, why am I doing this? Because as I said you, for the H bridge motor driver logic, what was the logic? One pin should be at higher potential, the second pin should be at lower potential, and in this case the current will be flowing for the H bridge. So for now I am making IN pin number 1 high and 2 low, so the direction will be set to a particular clockwise or anti-clockwise. Next, I need to set the speed. Okay, now setting the speed is also very important. So I'll write analogWrite and then pin. What is my pin name? That is enable A. And then I have the option of setting the speed. The range is from 0 to 255. Okay. So for example, I am writing here 100 and auto formatting done. Now let us quickly write the comments. Okay, this is setting pin to higher potential, here setting pin to lower potential, and this setting the speed of the motor, and the range is 0 to 255. It is a 8-bit controller. Okay, so the controller we have, which is our Arduino, it is a 8-bit controller. Okay, so 2 to the power 8, 2 raised to power 8 is 256, which means 0. If you are also counting 0, so 255, the total count becomes 256. Okay, so now what this code will do, up till now it will make one pin on higher potential, then second pin will be lower potential, and we have set the speed. So now the motor will start rotating. Okay, but after some time what I want is, I want the motor to stop for few seconds and then start again. Okay, so now for that I'll add a quick delay. Delay always we write in milliseconds. By default delay is in milliseconds. So if I want 1 second delay, I need to write 1000 here. Okay, so here I want, I guess, 2 seconds of stop after each rotation. So I'll write 2000 and then close the bracket, semicolon. So now the motor will start to run in a particular direction, be it clockwise or anti-clockwise, on at a speed of 100, and then it will stop for 2 seconds. Now what I want is the motor to rotate in other direction. Okay, so I'll quickly copy this, paste it here, and just interchange. So now IN1 becomes low and IN2 becomes high. Quickly formatting everything, and now here this is low and now this is on a higher potential. Okay, so now the direction will be changed. Okay, I'll quickly add a comment here. For example, this is clockwise direction So now this will be anti-clockwise direction. Anti-clockwise direction. And then again what we need, it should rotate in clockwise direction at a speed of 100, stop for 2 seconds, rotate for anti-clockwise at a speed of 100, and then again stop for some time and then start again with the same loop. So I'll add a delay of 2 seconds again. So now what it will do, clockwise wait, anti-clockwise wait, and again the loop will be continuously moving. Here you can see the loop will be continuously moving and the code will be executed in cyclic pattern and the loop function will be continuously working. Now I hope this is clear. This code will be also provided in the description. So now I will be showing you some debugging steps. When your code is done, first of all you need to save the code. To save the code, you can press Ctrl plus F and then save the code. So now this is motor driver L298N. Okay, motor driver L298N, or any code, any name you need to give, you can save it by that name and you'll get this message here, done saving. So once the code is saved, we need to attach the Arduino and upload it. But before that, we need to check if the code is correct. Okay, so for that we need to press on this verification button. Okay, but just to show you of how a code works and how the error is shown here at the bottom panel, I will what I will do is I will simply remove one semicolon from here. Okay, so you can see I have removed one semicolon after this line. So now I will quickly press on the verification. So now you can see it is showing compiling sketch, and here you can see the progress bar. Okay, so now you can see that we have got the error. We have got the error. Okay, so now can see, okay, expected. Okay, Arduino IDE is showing you what is the possible error. So expected semicolon before the curly bracket token. Okay, so before this curly bracket token, before this, okay, so before this curly bracket, it is saying that it expected a semicolon. So before this, it expected a semicolon which is at this position. Okay, so we'll can give the semicolon, है ना? So it will give you very properly, very clearly the error will be told, and it will also highlight the line. Okay, this line is highlighted means the error is occurred before the line or on this line. Okay, and the error is explanation is also very clear, expected semicolon before the bracket token. Okay, so this way you can check and debug your code for all the errors. Now I'll quickly press the verification again and we will verify for any further errors. Okay, so now as you can see, I've got the message of done compiling. So our code is successfully compiled and there are no further errors in the code. Okay, so it is safe to upload. So we can click on the upload button. So let us see what happens when we click on this upload. So first it will always compile. Okay, so when you press the upload, first it will again compile the code and then start uploading. But see, here you have a error, common error which is can't open drive com10, the system cannot find the file specified. Okay, so the Arduino was not found on the com10. So in this case what we can do, you can go on this tool. Okay, the tools menu, here you have board selection. Okay, in the board selection make sure you have selected the Arduino Uno boards. Okay, so we have multiple boards that is made by the Arduino, which can be Leonardo, Mega, Nano, Uno, Mini, Ethernet, Mini, Wi-Fi, Bluetooth. Okay, out of all this you need to select the Arduino Uno. Once that is done, at in the port section, okay, now there can be two possibilities. Either you are seeing multiple ports. Okay, either option. The first option is, the first case scenario is, you can see multiple options and you do not know which is exactly your COM port where the Arduino is connected. And the second case scenario is in which the port is not actually enabled. Okay, so it is kind of disabled, you are not even able to click on the port. So in that case, what we need to do to solve the comp problem, we need to go to device manager. So for that, click on the keyboard, Windows key, then search for device manager and quickly open your device manager. Here you can see all the connected peripherals to your computer or laptop. Okay, so currently my Arduino is not connected. Okay, so you need to properly observe what happens to this device manager menu when I connect the Arduino. You will also hear a connection sound, a particular connection sound which the laptop or computer will make when as soon as the Arduino USB is plugged in. Okay, so you got the particular sound, as well as you got this device manager also updated. Now here in this device manager, you need to search for this ports COM and LPT option. Ports COM and LPT option. You can double click on this, and then you will be able to see the accurate port. Okay, so now your USB serial CH340. So what is this USB serial 3 CH340? This is basically the bootloader. This is the basically this CH340 is the bootloader of your Arduino. So the bootloader of your Arduino is now talking with, using the serial communication, USB serial communication from your laptop and computer, and the communication is set on comp number 6 for my case. For your case the comp can be different. Okay, so once this is confirmed, it is on comp 6, you can go back to the Arduino IDE tools and then select comp 6 out of all the options, and then you can quickly re-upload the program. Here make sure you see the correct board and correct COM. So Arduino Uno on COM 6. Make sure you have the board name as well as the port correct. If everything is done, you will get this message uploading. You will get a progress bar and then done uploading. So now the program is successfully uploaded, and if everything is all okay, your circuit will be working. Okay, now in second case, if you are not able to see the port at all, if you are not able to see the port at all, just quickly check on your Arduino, touch it physically, and make a proper observation if your Arduino is getting heated above average. Okay, so in normal case your Arduino should be very calm and cool. But if it is getting heated, it means there is some short circuit, or maybe your Arduino is fried. So in that case, you need a new Arduino. If everything is fine, then done. But if Arduino is not getting, like Arduino is getting powered, okay, your Arduino built-in LEDs or on LED is getting on, but still you are not getting this port. If your laptop or computer is still not recognizing this port, what you can do is you can open your Chrome browser or any kind of. Okay, so you can open your Chrome browser and then search for FTDI driver install. Okay, so this is FTDI driver install. Fine. Now you can see this FTDI site. This FTDI site, you can click on the first link. Okay, from the drop down menu, what you can do is, however, here it is giving a click to download Windows 10, 11 or Windows Server driver installer or the setup executable file. This is very important, setup executable file. Okay, so you can click on this and then download the executable file. Here you can see the file is around 2.2 MB and the file is now downloaded. Now we can go to the download section and see. Here the file is there. Now I can quickly extract the file and then open it. Once you open it, you'll get this .exe format, application type file .exe format file you will be receiving. So you can quickly open that, click on yes, click on extract and then do all the further installation processes. Since it is already installed in my computer, my system, I'm not doing it again. Again, I am repeating, this FTDI driver setup is only for those students, those users where you cannot see the tools and also the device manager. In the device manager, you are not receiving such kind of USB serial. It means your computer or laptop is not recognizing the Arduino device using because of some driver not updating issue, not updated, up to date issue. So in that case you need to do the FTDI driver installation, not for everyone. Okay, so now this code is done. It will basically start the motor, stop it, change the direction and then again stop it. So now we will go towards our setup and then check how it is physically happening. Okay students, welcome again to the setup. This was the connection that we have made and now the Arduino is also well coded. Okay, so now I removed this negative connection, so I'll quickly place it back again. So now the motor driver is on, it shows the red LED, and now I'll plug in the Arduino. Okay, so now as you can see, this wheel is rotating. I'll quickly stop that, attach the wheel so we can properly visualize. Okay, quickly. Okay, so now it is clockwise stop, anti-clockwise stop. To make it more clear, we will stop this and then currently we tested it for 100. I will make it 70, so we will get a clear picture. And again instead of 2000 millisecond, I am making it 3000 millisecond, so we will get more clear vision. Again, if you are changing the port, you can check on the device manager and select the appropriate code and then upload. Okay, I've still not uploaded the updated code. Okay, so now I press the upload button. Now it will be updated. It is uploading now. Okay, so now the speed is reduced. Okay, it is stopping for 3 seconds and then changing the directions as well. I'll make it 60 and let's try if that works, so we will get more better understanding. So now it is more slow, so you can get a better understanding. That's it. Thank you so much. You can then disconnect the power cable from the Arduino. So the Arduino is now powered off. Next, power off the motor driver and then you are safe. Unplug everything and then disassemble it. Before removing any connection, what you need to do is first remove the battery connections. Since the battery is very dangerous, you can remove the battery connection and then the rest can be done later. First start with the middle cell and then remove the middle cell. So now you can keep it and then remove the other cell as well. That's it. Thank you so much.